Hey folks, welcome back. This time around we'll get into some actual talk about the content for the course. So last time we covered all the administrative stuff. This time we get to give a bit of an overview as to what we're going to cover. So there's good news and bad news for this. This is one of my absolute favorite courses, so hopefully I can get across some of the things that are really interesting about it, but it does mean I'm going to talk a lot all the time about all sorts of different things. So, I don't know. If you enjoy it, great. If not, I'm sorry. Okay, let's see. What did I want to get into for this? So, essentially, we want to get into both the theory and the applied side of programming languages in this course. So, the languages themselves, they're giving us a way that we can express a solution to a problem. Right? You've got your problem that whether it's, I want to give somebody a web browser that they can use, or I want to create a game or whatever it might be. The programming language that we're using is what allows us to express our solution. And the nature of the language impacts how we express the solution, and it kind of shapes the way we think about our solutions as well. So one of the things that we want to do when we're studying languages is to look at a lot of very different languages that give us very different ways of expressing what we're trying to do. And between them, you'll eventually find that different languages give you a way to focus on a problem from a very different point of view. If you learn and understand more styles of programming language, it lets you think about solving your problems in different ways. And that translates across languages. So if I'm used to programming in C++, but I've got a good understanding of some functional programming language, if I run across a problem where that other style is useful, it can help me to solve the problem even if I'm still working in C++. It gives me a way to visualize a different solution. So that's one of the things that we're really interested in looking at. And again, even if the language that we're working in right now doesn't support, feature X that's in this other language that we'd like to use, if we understand how that other language implements that feature, then maybe we can implement it or something close to it in the language that we do have. So it really builds up our capabilities as programmers, as software designer. So that's one of the things that I want to focus on. Towards that end, I want to look at a bunch of different programming paradigms. So these are essentially different styles or approaches to programming. There's a lot of debate on what quote-unquote the programming paradigms are. Ask a bunch of different academics and you'll get a ton of different answers as to, this is the 4 set of programming paradigms that exist, or these are the 5, or these are the 16, or whatever it might be. I'm going to look at 4 in some detail. Again, there's lots of debate on this. The idea is in getting a good breadth of understanding of different approaches. And I don't particularly care about the specific definitions of the language themselves. It's the nature of the problems that we're trying to understand and the way we can express our solutions. So I am going to divvy it up into 2 broad categories, and then I'm going to divvy them up further. I'm going to divide this into the sort of imperative and declarative style. In an imperative style, I can't spell. In an imperative style, we go through and give the specific sequence of actions that have to take place to solve the problem. Right? This is our typical sort of C++ Java approach to solving a problem, where we say, do this, store a value in this variable, change it here, call this function, do this. You give an exact sequence of instructions to figure out what the solution happens to be. In a declarative approach, essentially they provide us with a means of saying, here are the rules of the language, here's the thing I'm trying to solve, and somehow you let the language work the rest out for you. You don't necessarily provide a specific sequence of events. So we'll look at how some of those languages work in a little bit. So on the imperative side, I'm going to divide these up into the sort of procedural and object-oriented. And again, there's a lot of overlap and there's a lot of hybrids, but the procedural are the cases where you're going through and describing step by step, again, the exact sequence of actions that we're going to perform. So this is the kind of C bash style, right, where that's really all we have. You've got functions, you've got loops, you've got variables and assignment and that kind of thing. The object-oriented approaches take that, but also add the ability to sort of encapsulate operations together with the data associated with an object. So you've all done OO work by now, right? We're looking at the idea of having fields and methods, if you like, where you've got the operations on the data that you've got stored. And often those operations are expressed in a fairly procedural fashion. Right? So it does tend to encompass the two of them. Now, in a pure OO approach, everything is an object. It's relatively rare to have pure OO languages. Most languages give you kind of an OO feel, but with some things that aren't pure OO. So you might have things like integers or other primitive types that aren't necessarily always treated as an object. So there's lots of hybrids, lots of cases where you've got a sort of the pure version of a paradigm, and in practice, most languages aren't all that pure. They give you the advantages, if you like, but they stray a little from the pure path to make some things more practical. Then on the declarative side, there's a couple of different ones that we'll take a look at here. The logic programming side, if you've ever worked in Prolog, if we tormented you with that in 162, for instance, then you've done some logic programming. And so in this case, the idea is you come up with a set of facts and rules that describe the way your universe of interest works. And then you make a query and say, okay, using those facts and rules, can you do blah? Or what is the answer to blah? And then the logic engine is responsible for combining those facts and rules to come up with a solution for your query and give you the answer. So the programming part is in how you build those facts and rules and how you express your query, and you leave it up to the engine to figure out how to work out a solution from those two sets of things. So again, this is the declarative idea, that we're not giving the specific sequence of steps to take to arrive at a solution. You're taking a different approach to expressing and solving the problem. On a functional programming approach, we're simply going to express everything as either a function call or data. And we're going to throw away the idea of having variables, any kind of stored state. We're going to throw away the idea of functions having side effects. There's no pass by reference. There is no reference idea. There's no pointers. There's no whatever. All we're going to have are function calls and data, values. And the way we're going to do our programming is by composing sets of functions and function calls as parameters to function calls as parameters to function calls as parameters to function calls, and let the system work out the order that different parameters are evaluated in. Let the system work out what sequence the function calls are evaluated in. It's all stuff that we won't need to worry about in a pure functional programming approach. And again, there are a few pure functional languages, things like Haskell, but most functional languages are actually a hybrid of kind of procedural or procedural and OO with functional. So they give you they give you support for functional programming, but they also support some more procedural approaches. And again, for the most part, this is trying to give developers the best of both worlds. Is usually the idea with a hybrid language. You're trying to provide functionality from this and functionality from this and let the developer use whichever one they want. So Lisp, the common Lisp that we're going to use this term, for instance, Scheme, Erlang, there's a whole slew of different hybrid functional languages. And again, we'll get into the gory details and how this all works a little later in the term. Well, pretty darn soon, actually. So there's the theory side that we're interested in, and then there's the implementation side. For a given language, how do you actually make it work on a particular piece of hardware? And for those of you who are also taking the compiler course right now or who are going to take it in the future, we'll get into much more detail on that in that course. But we're going to get into some interesting nuts and bolts for it in this course. So if you look at a class, if you've got a C++ class, how does that work at the assembly language level? If you've got pure virtual methods and that kind of thing, how does that actually work? How does this class in C++ source code turn into a bunch of assembly language instructions to do what we want it to do? The implementation that you use has a huge impact on how effective the language actually is, how efficient it is, right? How fast it runs, how much memory it uses, all sorts of different things, reliability, security, how easy or difficult it is to develop debuggers and compilers and things for the language. Those are all impacted by how we're going to choose to do our implementation. So there are lots of implementation issues that we want to begin to understand. As a developer, we want to be aware of what the implications are because they impact how we wind up using it. If I use recursion in language X, how nasty is that going to be in terms of chewing up stack space, or how nasty is it going to be in terms of runtime? If I use classes and pure virtual methods and whatever else it might be, what is the impact on my program when I actually run it? Right? What does the implementation that was chosen do to my programs as they're running? Now, again, I think I was mentioning this earlier, if we know how we can implement, or if we know how a feature is implemented in one language, then even if it's not supported in another language, maybe that allows us to figure out how we can do our own version of that in the other language. So this is something else that allows us to port knowledge across different languages. And again, the better breadth you have in understanding programming languages, the better you are as a developer as a whole. All right, so we'd like to spend some time and explore some of the programming languages that are out there. There's a few that we're going to focus on, but there are a ton of different programming languages out there. If you go through, and the counts I've got here are probably out of date already because it's been a couple of weeks since I wrote this, but there's a huge library of programming languages and some common programming tasks available at Rosetta Code. So they've got one page that gives you this big list of programming languages and another list of programming tasks, and they cross-reference them. Here's this task solved in all these different languages. Here's this other task solved in all these different languages. So if you're ever bored and feel like exploring, pop over there. And again, there's this huge long list of every language, well, it's not every language under the sun, but this huge long list of all the different programming languages out there. And again, you can pick your language and it'll go through and give you solutions for a whole bunch of different tasks in that language. So if you want to go through and just find some new language that you've never heard of before, oh geez, I've never actually looked at Peloton. So take a look at the programming language, take a look at how they've solved different problems in that particular language. And again, it'll give you examples of code solutions. Doesn't look like they've actually coded that one. Okay, well, never mind. Let's find another one. I'll babble away here. So again, basically the idea is pick your language. So let's say we pick Common Lisp, since we're going to play with that a lot. Pick your task. Well, let's just look at nested loops. Nothing too terribly complex. And again, you can go through and somewhere in here, hopefully, there we are. We do actually have code for, what have I done? I'm lost. There we are, Common Lisp. It's in there someplace. So you can go through and for that task, for your language, find the code in that language that accomplishes the given task. So again, it's just something, it's not something that you have to do for this course, but it can be a really interesting site to explore just because of the sheer breadth out there. Okay, again, just in terms of a few simple examples, if we were going to go through and look at a particular task in a bunch of different languages, you think about what a solution might look like for doing push on a simple stack in something like C. Right? You wind up going through, you're going to need a library or two, you need to go through and create the data type that you're going to use, you need to go through and create the function for it, and there's this very specific sequence that you wind up going through. Now here I'm using dynamic allocation to go off and do this, to allocate a new node that we're going to push on top of a stack. So we've got essentially a glorified linked list here, where we've got a node that contains some data, and we're just pushing elements onto a stack. Right? You've got somewhere off in your main routine or wherever this thing's being used, you create your empty stack, and you go off and push something onto it. Right? So there's all sorts of different options, but again, you think about what a solution might look like in a specific language. And then you look at a different language. So if we were going to go through and use the standard template library in C++, you might wind up with a very different solution. Right? Where you're going off and saying, okay, well, create a stack of the desired data type and apply the push method to it with the data that I want to use. Or if you wanted to use something like Lisp. So here we're actually implementing a stack as just a simple list of data, and so all we're doing is sticking a new element at the front of the list as we go. So I'm going to go off and create a function that takes the existing list and the thing that I want to push and adds this new thing at the front of the list. Right? Maybe we've got a function to define a new stack. Maybe we've got a function to push a value onto an existing stack. So create a new stack and push a value onto it, for instance. But again, the appearance and the behavior of the language, or of the same task in the different languages, can be very, very different. And that's sort of where we want to get to, is thinking about how the language shapes the way we're going to look at the problem and shapes the way our solutions are going to look. Oh, Prolog as well. Why not throw a logic programming example in? So this is one of the languages where we go through and define a set of rules about how the world works, and then issue a query. What happens if I try and push something onto a stack? So we go through and create a rule that defines an empty stack. We create basically a fact expressing what an empty stack looks like. We express what a non-empty stack looks like. We come up with a rule for how to push something onto a stack. So if I've got some element and I've got some stack, then if I want to push an element onto the stack, it's going to wind up looking like this. So we can go through later and create our empty stack and then say, okay, please try and push this value 10 onto this stack S, and the result is going to wind up here. And so what happens is this goes off and runs your query and says, okay, is there something that tells me how to do this to come up with a result? Right? I'm going through and declaring an empty stack, and I'm saying try and push some value onto that stack and figure out what the result is. And so the Prolog engine is going to go off and say, well, do these facts and rules give me some way to resolve this and figure out what the result is? Again, it's a very different way of thinking about the programming problem and a very different way of expressing your solution. And it's all geared around the language that we're choosing. So these are the kinds of things that we want to investigate over the course of the term. And we'll get into some of them in much more detail than others, but it does lead us in all sorts of really interesting directions. Well, interesting to me. Hopefully it winds up being interesting to you as well. All right, I will shut up for now, and we'll pick things up next week.